Session 3. Neural Networks Basics. Neural networks are the digital version of the human brain. They are the core technology behind modern AI systems, image recognition, speech processing, translation, and even models like ChatGPT. In this session, we break down how they work in a simple but powerful way. 1. What is a neural network? A neural network takes an input, processes it through several layers, and produces an output. It has three main parts: input layer, raw data enters; hidden layers, where patterns are learned; output layer, final prediction. Now let's go 2. What is a neuron? A neuron is a small mathematical unit that decides what information matters. It uses weights, importance of each input, bias adjustment factor, activation function, decision maker, formula, output activation WX plus B. 3. Why activation functions matter. They make the network non-linear, allowing it to learn complex patterns. Common ones: ReLU, fast and widely used; sigmoid, outputs between 0 and 1; softmax for multi-class classification. 4. How does a neural network learn? Learning happens in 2 steps. 1. Forward pass. The network makes a prediction. 2. Backpropagation. It compares prediction with the correct answer and adjusts weights. This improvement process uses gradient descent, making the network smarter over time. 5. Practical example. Imagine training a network to detect whether an image contains a cat. Input, pixels of the image; hidden layers, learn features like ears, eyes, whiskers; output, probability, e.g. 0.92, this is a cat. Neural networks are powerful because they learn patterns automatically, improve with more data, and can model extremely complex relationships. Understanding neurons, layers, and backpropagation gives you the foundation to learn deep learning, CNNs, and even transformers with confidence.